we just saw how to multiply two fractions, and next we have to divide fractions. So how do you divide two fractions? The answer is you do not divide two fractions. You actually turn it into a multiplication problem. So when you're asked to divide two fractions, the process is going to be like this. Leave the first fraction alone, don't touch it, don't mess with it, but multiply by the reciprocal of the second fraction. The word reciprocal or inverse means to flip something upside down. That's what it means to say the reciprocal. So the reciprocal of 1/2 is, for example, 2/1. The reciprocal of 3 is the same thing as 1/3, because 3 is literally 3/1. So when you take the reciprocal or the inverse, it turns into 1 divided by 3. So if somebody says, how do you divide two fractions? You will say, I don't divide two fractions. I turn it into a product and multiply with the reciprocal of the second fraction. So let's give it a shot. Here's a few examples. Let's take a look at the first one. 10 divided by 7, all divided by 5/6. How do you divide these two fractions? Well, like we said, we're going to change this division into multiplication. So we leave the 10/7 alone. We don't mess with it. And we turn the division into multiplication, provided that we look at the reciprocal or inverse of the second fraction. So 6 divided by 5 is the reciprocal. And again, the way you multiply fractions is you go straight forward, 10 with 6 and 7 with 5. Before you actually perform the product, try to reduce it. 10 and 5 can both be divided by 5. So write down the 2 and also write down the 1. Now, I keep writing down the 1, and some of you will probably not write down the 1. Just a warning, it is important to write the details in math. If you don't write the 1, you will accidentally make mistakes later on. So keep writing. It takes 1 second to do it, but it saves us from making terrible mistakes later. So 2 times 6 is now 12. 7 times 1 is 7, and that's the end. Same thing again if I have 18/13 divided by 27. Keep in mind, 27 is literally 27 divided by 1. So how do you divide these two fractions? Literally, you turn it into a product. So again, the division goes away, we get multiplication, and we take the reciprocal of 1/27. Of 27/1, which is 1/27. So now it's 18 times 1, all divided by 13 times 27. Again, before you multiply, look for things that you can reduce. For instance, 18 and 27 can both be divided by 9. This gives us 2. This gives us 3. So 2/39 is the final solution. So finally, with example 15, the setup is a little bit different. It looks like I have a fraction divided by a second fraction, but the format here is a little bit different. We call these things complex fractions. And that term just really means that we have a fraction within a fraction. That's what we call complex fractions. And so in this case, the division sign is that one right there. And we need the reciprocal of the second. So 7/9 stays there. The division that was there turns into multiplication. And we take the reciprocal of 42/15, which is 15 divided by 42. So regardless of whether they're using the old notation, the division sign, or they're using the complex division notation, does not matter what's written down. We always do the same thing. Leave the first fraction alone, multiply by the reciprocal or the inverse of the second one. So again, 7, 15, and then 9 and 42. So again, I'm going to try to divide the terms before I multiply. So for instance, 7 and 42 can both be divided by 7 to get 1 and 6. Similarly, the 9 and the 15 can both be divided by 3 to give me a 3 and a 5 there. And the leftovers are 1 times 5, which is 5, and 3 times 6, which is 18. And that's the final answer. So even though these problems are pretty straightforward with simple numbers and they can be plugged into a calculator, the reason why we're doing them is so that when we get to the problems that have x's and variables and y's and you have to divide and multiply things with polynomials, the process will look familiar.